Hello and welcome back. Today we're going to add Spdlog to our game. And basically Spdlog is a fast C++ logging library. It's pretty de facto, it's very standard, a very easy choice for a lot of people. And it's very easy to use, it's header only, so it's here on GitHub, it's Spdlog. So you just pull down the code, which I've done already, and you'll get something like this. You can build this from source. It is an include only, so you can actually also drag it in to your project, which is exactly what we're going to do here. So in our external, I'm just going to add a new folder. We'll call it Spdlog. We'll go in and we'll create our include folder. And actually, I believe they already support this folder structure that I like. So include Spdlog and then every include file. And it's again header only, so that's awesome. Just copy and paste that in. I also want to take the license here, which is MIT. So because it's header only, we can just build it into our executable, and we don't actually need to link to anything. We're just going to add the includes. So let's switch over to Visual Studio Code so that we can modify that premake5.lua file. So here, again, it's very straightforward. We just add another externals, this time for Spdlog. And then we just include it. And we're really just going to need to include it at Hippo. We're again going to obfuscate the ability to use Spdlog to the rest of the include projects that are using it. And that's all we need to do. So let's just genSLN real quick. And I have Visual Studio open. So if you genSLN while this is open and it actually makes a change, you just tell it to reload. And there we go. Now, last video I talked a little bit about the architecture of what we're going to build here, and I mentioned the managers or the subsystems, and we're going to sort of set up what that looks like, with the LogManager being the first manager that we write. So I'm going to create a new folder, managers, and Control-Shift-A to create a new file here, LogManager.h. So again, I'll create a new namespace for it. And my class will go here. I actually don't need a private section. I'm just going to have an initialize and a shutdown. So that's basically how our managers are going to be set up. We're going to have an initialize and a shutdown so that the engine can decide when to initialize and when to shut down each manager class. Now I'll create the CPP for it. And now we can actually go ahead and start using Spdlog. And I'm really just going to take from their examples and set up a sink. And a sink is basically a target for the logs to end up in. And you can have a sink that targets stood out, like standard output. You could have a sink that targets a file, or various other sort of things like that. So I'll include Spdlog sinks stood out color sinks. So this is standard out with colors available, basically. I also need to include Spdlog itself. So again, this is going to be basically following exactly the structure they've used in their examples. So the first thing you do is create a shared pointer to a sink that you want to set up. So I'll call it console sync. And of course, we're dealing with memory here, so we can include memory. So we'll do a make shared Spdlog sinks. Oops. Stood out color sync empty is what we're looking for. There we go. And then we can set the pattern that we want the print to look like. So basically a print statement could look like open square bracket, the year, dash the month, dash the day, and then maybe a space, and then the hour, colon the minute, colon the second, even dot the milliseconds if you want, and then the actual error message itself, or log message. So we can actually define exactly what this pattern looks like with a call to set pattern. And I think I'll do exactly what I wrote. That's what I've done before as well. So it's all a string that it'll end up parsing internally. So we'll do the beginning, open square bracket, the year, dash the month. Month, notice the M is lowercase, that's so that it's not confused with minutes. So year, month, and then day. Again, %D. And I'll do space, capital H for hour, colon, capital M for minute, colon, capital S, and then dot %E for the milliseconds. I'll close that square bracket, and I'll do %V, $$. So %V will be the actual message itself, and $sign marks the end of it. Okay, now Spdlog supports multiple syncs, as I mentioned earlier. So ultimately what you end up giving it is you register a logger that it consists of multiple syncs. For now we're just going to set up one sync to standard out, but we're going to come back here and add a sync for a file as well, so we can have log files that are logged to disk. To set us up for that sort of in the future, and also to support the API that Spdlog provides for us, we're going to create a vector of sync pointers called syncs, and we'll just give it the console sync that we created since we don't have anything else to give it. And then we create that logger. And we'll pass in a default logger name. That's sort of what it takes. We could just call it like hippo logger, right? This allows you to log to various loggers, which may have various syncs and that sort of thing. And then we'll just give it syncs.begin and syncs.end. Now we can set the level of the logger. So we want it to print everything basically. I might trace or debug or error or fatal. I want everything to be printed. So logger set level, and we'll just do Spdlog level trace, which is the lowest level. I also wanted to flush on trace. So flush on will just ensure that it flushes properly either to standard out or to a file every time it receives a trace. For example, you could do something where you set the level to trace but only flush on errors, and every time there's an error, that's when it'll flush everything out. But for our purposes, we'll want them both for trace. And then finally, you do the Spdlog register logger, and we pass in our logger. And as you can probably tell by this line, Spdlog does maintain state internally, and it has a reference to these loggers, and it stores everything for you. And then with some Spdlog calls, you can just refer to a logger and make a call to log something. And then of course we shut it down when we shut down the entire manager. Now I usually like to have any sort of logging mechanism sitting behind macros. The reason for that is that you can disable them in certain builds, like release builds. It makes it really easy to do so. It also makes it really easy to log things from anywhere, just because you can very easily use variadic arguments in your macros there. So we're going to do that. And I'm going to do that by creating a new file. I'll just call it log.h, because this will be basically what anything that wants to log, they're going to include this. They're not going to include the LogManager at all. It's just going to be the log.h. And log.h itself is going to define these macros that will ultimately call Spdlog functions. So we can just define, we'll call it hippo trace, and that'll be the first one, right? And it's ... because it takes variadic arguments. And now calls to Spdlog actually need that logger name, as I mentioned before. So maybe I'm actually going to define that even up here as well. So define hippo default logger name, and we'll call it hippo logger. You could also have Spdlog print this out with every line as well. We didn't put that in ours. But now that I have it there, actually, I'm going to go back to LogManager and just use it in place here. And I'll now need to actually need this in log.h. So instead of including Spdlog here, I'll just include log.h from here. I'll place this guy here. Okay, and so now I can actually make that call to Spdlog to execute a trace. So if Spdlog get hippo default logger name, I always do this check. If it's not null pointer, then I can do a dash arrow call on it, because the call is Spdlog get that logger dash arrow trace, because I'm defining what our trace statement is here. And the Spdlog method allows for temporary or for variable arguments as well, so we can just pass in our arguments with underscore underscore va underscore args underscore underscore, which just basically takes anything that I might pass in here and forwards it through to this call, if obviously it's available. Now again, I mentioned macros because we can turn them off, right? And that's very important. So really, I only want this enabled if not defined hippo config release. Otherwise, I want to define hippo trace to nothing. And some compilers don't like some compilers let you just leave it empty like this. Some don't like that. So if you do a void 0, that's just a very easy way to knock out that code, and all compilers will allow for this. And sorry, that should be casting 0 to a void. That's what we're doing there. So to put it to use, I really need this LogManager to be initialized properly so that Spdlog is set up. Otherwise, this call, this get will fail, it will be null pointer, and nothing will happen. So that's where our engine comes in. We're going to include our manager, LogManager, and we'll just have an instance of it here. So all of our managers will live here, and again, I explained this before, it's so that our engine can own this, it can define the lifetime, it can initialize in the correct order. So let's create a LogManager here, and then we'll initialize it properly in the CPP. So really, I want to do it right before we do anything else, because if this fails, I want to be able to replace this with a call to Spdlog, so I can log everything properly. So I'll do it at the very beginning. Initialize the LogManager, and we'll shut it down when we shut this down as well. And you usually shut them down in reverse order. So if you initialize your LogManager first, you want to shut down your LogManager last. Usually, that's just you know, depends. Absolutely depends on the architecture and the structure here. Then we can shut down SDL here. Yeah. Now to test it, let's just take one of these, like for example this debug, or maybe even at the very beginning. Just regardless, we'll just print something with this hippo trace. So I need to include log.h. Maybe we'll just do a hippo trace, hippo engine, and then I can pass in arguments. Like I said, it takes any number of arguments. So if to prove that, the way you do it in Spdlog is you put these curly braces, and just in order they'll match up to the next argument. So hippo engine, I can say, let's say version 0.0 for example, or 0.1. Let's say we want to do a major minor version thing. We'll do 0 and 1 here. So we should see a hippo engine version 0.1. Now this is complaining because it expects a semicolon, and that is very true. I need a semicolon at the end of this call here. So if we just go back to our engine, that should be fine now. And then get info, we currently call it in the constructor, which it actually won't work that way anymore because we haven't initialized our subsystem then yet. So we'll have to do that maybe here right after. We'll just call get info, and it should call that trace. Okay. Okay, so I think that's all we need to do. So let's just give this a run. Main is calling our engine.run, of course, which is setting us up by calling initialize. Initialize will initialize our log manager, and get info will attempt to use the log manager. And if everything looks correct, we should see a proper trace in the standard output window. And you can see that we do. And here's that formatting that I was talking about. So the year, the month, the day, hour, minute, second, dot milliseconds, hippo engine version 0.1. And you can see it concatenates everything properly with those squiggly brackets there. So that's awesome. I think the next step is really just to create an interface for every sort of log method that Spdlog supports. So let's do that now. So it has trace, debug, info, warn, error, and fatal. So I'm just going to go ahead and change these real quick. And actually fatal, I believe it's called critical. Yeah, I've always called it fatal. I think I'll leave it fatal. It doesn't really matter what we call it here. But the method internally within Spdlog is critical. And then again, you'll want to make sure that you disable it. And maybe I'll just comment here, like, disable logging for release builds. And actually, Visual Studio is easier if I just copy, paste, and then just Alt-Enter. And I don't know how it does it with multiple lines. Yeah, it kind of breaks when a line rolls over. So I'm just going to zoom out a little bit just so that my multi-line selection works easier. There we go. Maybe I'll leave it at this. Let me know if this is not large enough. I think it's easier to see more code this way. Okay, so now we should have the ability to do all of them, and ultimately what you'll see is that we can either filter by certain log levels, or we can just see that they look different. And I think that's very important visually to see that they look different. If we switch back to engine, I basically now should be able to remove any call to std_out. We should even remove IOStream and then just fix anything that breaks. Because I really don't want to use this anymore. I want everything to go through the log manager so that when we go and add a new sync, we don't miss a place. So here, the equivalent to an error would be a hippo error. And it would be error initializing SDL2, and then I'll use the squiggly brackets with a comma to get the error itself, and close the bracket. That's basically how I would convert each line. And this is why we've done it so early. I really want to make sure that we do this up front so that we don't have to come back and fix all of these later as we add more code. For the version, I don't have to use error, obviously. Maybe I'll use info. So it would be SDL, and then I said version major.minor.patch. And we'll just do a comma here. A little more intuitive now. It's a little closer to printf, right? But obviously much more flexible. I believe you can also put things within the squiggly brackets to maybe do some zero padding or decimal point sort of differentiation, that sort of thing. Okay, let's move on. Another fail. Down. This is easy. And then these, yeah. So maybe we'll, just to see them all, we'll just make these different. Like we can make the configuration like hippo debug, and we can make the platform hippo info. I've already used info, but what else do we have? Info warn. So maybe I'll use warn for those. Yeah. Okay, so we've got trace, debug, warn, we have some errors, we have info. The only one we don't have is fatal. And I think that's okay, we'll leave fatal for something else that I have in mind. Okay, so that's good, that's engine. Let's switch over to window and let's just do the same exercise here. This one was much quicker. And that should be all it takes, so let's just run this and give that a shot. And there you go, you can see that trace is white, debug is blue, warn is yellow, and info is green. So we have these sort of different abilities, and we haven't seen error yet, obviously. Let's just real quick, we'll go to our engine and we'll just pretend that we failed to initialize. Simply add an or true, you can make sure that it goes into this break, into this section. And we should see an error initializing STL, and the whole thing should actually end very quickly. You can see that it does. And sometimes this command window doesn't, like, it hides itself and the program runs for some reason. If anybody knows how to fix that, let me know. You can see obviously though, error initializing STL2, there's no error, and that's valid because we forced it. There actually is no internal error there. And then ultimately that causes the engine initialization to fail, which shuts down, and then we press enter to continue. So you can imagine a situation where we're debugging something, something's breaking sort of in the middle of the build. If we were printing this all to a file, you'd be able to quickly come through and see which errors we're hitting, and then be able to determine what the problem was. So let's remove that. And that's we're already in a really good place, and this should really be a testament to Spdlog itself and how easy it is to get everything working. They've done a lot of the heavy lifting for us, so that's really great. Now, one last thing I wanted to focus on today is sort of related here. It's asserts. And asserts, if you're not familiar with the term, it's really just a way for you to assert that something is true, or that a condition is expected. So for example, initialize. I know initialize should only ever be called once. If somebody tries to call initialize more than once, I should assert saying, hey, this has already been called once. And the assert isn't meant to capture user error. It's not meant to capture user an error that a user might face, that a user will have to deal with. It's very much meant for us to find during development so that we know that there's some code that is causing initialize to be called twice when we know it shouldn't be the case. And it helps us find bugs that way. So let's go ahead and add the concept of an assert. So for this case, again, we need to know that we've already called it, that we've already been initialized. So let's just add a quick flag. M is initialized. We'll initialize that flag to false. And every time I have more than one, I like to put them on new lines. It's much easier to read this way. And so when we shut down, down here, we should set that to false. And then when we are initialized, we should set that to true if everything was successful, right? So I guess I can do like an if ret. Or no, I can just do it up here. This is our basically we're good block, I guess. We could just set red and then do everything else down here, so it's easier to find, but you know, we'll do that if we feel like it's necessary. For now, it's fine up here. And now what I really want to do is assert if we ever call this while MS initialized is already true. So an assert is pretty straightforward, and we usually want to do a couple of different sort of options in terms of things when you assert. You want to print out the assert message itself. So what are you asserting on? Where did the assert occur? In terms of file name and file line, like line number, and also the ability to break into the debugger if possible. So all of that we can actually do from log.h because we can simply add, again, asserts are not something we want on release build, so we want an hippo assert, and then we can pass in not just variadic templates or variadic arguments here. In fact, we're going to pass in a very static string with no variadic argument supported. So we'll pass in the x, and the x is what are we asserting on, and the message is what should we print if the assert is false, basically. Okay, and this will be there's a lot of ways to write an assert, and usually it breaks out into, it expands into code that is like if not x sort of thing. There's a really good article somewhere, I'll try to find it, That really explains on a lot of the different caveats of why you should write asserts a very specific way. For example, if not x, I can just do something in line here. If I don't have my curly braces, this could already be within an else case, or before an else, or inside of another if that is an inline sort of single line if statement. There's a lot of different ways where your assert could actually break the code you're trying to write. And so ultimately what it really has been decided is you do 2 brackets with an x, because again, this could have brackets internally, it could have a whole bunch of stuff. You don't know, it expands to whatever the user passes in. And by user I mean the engineer writing the code. So we'll do double brackets to protect ourselves from breaking out of that if statement. And then nothing, so if the assert is true, if we are correct in our assumptions, then nothing. And then else. And this is sort of the best way to protect all of the various cases that might happen when you put a hippo assert somewhere in your code, sort of inline again, in single lines if statements, that sort of thing. So when we're here, we'll actually want to call our hippo fatal, because this is our sort of critical. It'll be very clear, and you'll see it when we run this. And I want to print out a very specific message. So I want to say there's an assert, and then I'm going to pass in basically what are we trying to assert on. So we're going to stringify x, and then on the next line we'll put the message itself that we want to print, right? So if and you call initialize twice, and that x ends up becoming false, a message could be you are trying to call initialize twice, that sort of thing. So this is sort of our context. And then we'll go to the next line, and you can see I'm doing a /n/t. It's just the next line and a tab in, just to format the output message a little bit. And then we'll put in the file name, so in file, and then again you can do these. This is Spdlog formatting, right? And then /n/t online. And then to get that data, again, we're going to stringify x, so you just do that with the £x. We're going to pass in the message that we passed into this. And then you get __file__, and then __line __. And I believe there are new ways of getting this data. I don't remember if it's C++ 20 or earlier, maybe. I don't think it was 17. I think it might be 20. But either way, these are only allowed sort of within macros, and that's fine. We are using macros, and again, we have a very legitimate reason for it. We want to be able to quickly knock out all of this code if we're in release build. So, and then that's it. We will print this message, we will semicolon, and that's the end of our else statement. So let's just see at the very least if our assert works and we get a nice message. Switching back to our initialize, I now want to assert here. I am basically saying, and the syntax is sort of hippo assert, and then I say I am asserting that m is initialized equals false, right? Or I can just say not m is initialized. That is sort of what my expectation is. And if that's not the case, I want to print out attempting to call engine initialize more than once. You can see how clear this is. The intent is very clear. Engine initialize should only be called once. If I ever see this assert, I know exactly where to go look for it. And so just to trigger it, let's just call initialize twice here, right? So let's just, and we have a no discard on this, right? Yeah, we have a no discard, so we have to capture it somehow. So we'll just say auto x equals initialize, and you can see that obviously by the second time around, we're going to actually assert, or we should assert. So let's run this. Okay, we actually ended up crashing, so let's see what's happening here. Spdlog is crashing if a logger does not exist. And yeah, this is actually very, very interesting. We should have triggered our assert. Yeah, and so this is crashing because the logger. It looks like the logger already exists, right? Throw if exists. So logger with name already exists, and if we look at what it's actually throwing, this message, it actually looks to be empty for some reason. I would have expected that to be sort of their error message that they're throwing, but it's very clear with the call stack that we're trying to register a second logger with the same name, and that's very true. We're not doing anything if we are calling initialize twice, right? And this is exactly why we want this assert. We don't actually want anything to happen here. So we really just want if not m is initialized. And you'll actually see this paradigm a lot. An assert is usually followed by an if statement. So you can protect against exactly this sort of thing. So you just put everything internally, just have our bool false at the top so it's more clear. So we're going to return false on the second time if that is the case. And let's try that again. There we go. So you can see that we assert, and it's very clear. What we're asserting on is that m is initialized is false. And we're attempting to call engine initialize more than once in engine.cpp on line 41. And that's exactly where the assert lives, right? So this is great. This is exactly what we want. Now, what didn't happen is we didn't stop anything from happening, right? We prevented it from here, but if I was to put a breakpoint here, obviously I hit it the first time where I haven't asserted yet. So I'll just F5, and now I hit it again, right? Like, even though we've asserted, the process still went on to the next line, right? It's still going to continue executing code. And really what I haven't given myself as the engineer working on this is a chance to inspect this assert, right? Maybe if I was to break on this assert, I would get a call stack telling me exactly who called initialize the second time, right? So we can actually do that. And again, we'll go back to log.h for that. Now this is platform specific, so again, our Hippo platform defines are going to come in handy here. And it's really just a couple of sort of built-in methods that let you break into the debugger. So if defined Hippo platform windows, we're going to define Hippo break. And that's what I'm going to call it. If I call Hippo break from anywhere, it's going to attempt to break into the debugger. So Hippo break, and then you call the method for Windows is __ debug break. If I can spell. There we go. And then we'll do an elif defined. We'll do Mac next. For Mac, we're going to redefine Hippo break. No, it's actually redefine. It's defining for the first time because this will never get hit on Windows, on Mac, for example. And here it's called __ built-in _debug trap. And again, for Linux, it's actually just __ built-in _ trap. And you know what? I'm actually going to do an else here, just in case there's any other platforms we ever try to build this on. And they'll all fall into this. And usually other platforms like consoles are Linux based, at least as far as I know. So this sort of thing should work in those sorts of consoles. So now, after we assert by calling Hippo fatal, we should actually be able to call Hippo break. And you can see the semicolons are included in Hippo break, so I don't need a semicolon at the end here. I just call Hippo break directly. And sorry, obviously no brackets if you're not passing any parameters in. Just Hippo break, which will expand to one of these three. And that's all it takes. So now if I run, and let me just make sure my breakpoint is off, and it is. So if I run now, you can see I'm immediately thrown into the debugger, and I'm thrown right here. So we have triggered a breakpoint. It's the exact same as if you had a breakpoint on this line. And you can see I'm breaking on this assert, attempting to call engine initialize more than once. I could look at the output here if I wanted to. I could also come here and look at the call stack, which is really what's interesting, because now I can tell, okay, this is the second time we're calling initialize, so why is this code calling it when we already have called it? Obviously, in a case like this, it's very, very trivial. We obviously did this on purpose. But again, you get the idea. It lets you break in and inspect the code. So by removing that, we now have the ability to assert. And again, at the best case scenario, you never see one, right? You never want to see asserts, but when you do, you're glad you have them, because they'll help point you in the right direction in terms of trying to figure out what that bug might be. And that's it for today. Thanks for watching.